Good evening. You're watching Breaking Logics, where ones and zeros become breaking news.
Tonight's top story: four brilliant engineers from Team 14 have achieved the impossible, constructing 5 functional logic gates from scratch.
That's right. From not to XOR, they've turned their breadboards into brilliance. Let's go live with two of the engineers that constructed these masterpieces. Meet Hemail Mamadova and Shahin Guliev.
Good evening, Nihad and Ilahe.
Thank you for inviting us. We are going to explain how to build NOT and or NAND and XOR gates.
Let's start with NOT gate.
To build a NOT gate, connect the power supply so the positive rail is plus 5 voltage and the negative rail is ground. Place the LED with its short leg to ground and long leg through resistor. Connect the push button to the positive rail as input. Use an NPN transistor as a switch with a 2 kΩ pull-up resistor between the push button and base to limit current. Jumper wires connect the collector to the 330 ohm resistor and the LED anode, and the emitter connects to ground. The 330 ohm resistor protects the LED. When input is low, the transistor is off. Current flows through the LED, the output is high. When input is high, the transistor turns on. Current flows to ground and the LED turns off, the output is low.
Pressing the button inverts the LED state. If the light is on, it goes off, and vice versa.
After successfully creating the first gate, our engineers were hard at work building gates that believe in cooperation, the AND and OR gates.
To construct an AND gate, connect the power supply to provide voltage for the transistors. Place 3 NPN transistors on the breadboard as switches forming the logic function. Add an LED as visual output, connecting its cathode to ground. Place a 330 ohm resistor in series with the LED to limit current and protect the LED and transistors. Place a 2 kΩ resistor between the transistors to control base current and ensure stable biasing. Connect 2 more 2 kΩ resistors from the bases of the first 2 NPNs to push buttons linked to the positive rail. Pressing both buttons allows both bases to receive voltage, fulfilling the AND condition. Connect the LED and output transistor through the 330 ohm resistor. Tie the emitters of the input transistors to ground. Connect collectors and emitters in sequence so current flows only when both input transistors conduct. Use jumper wires to connect each transistor to its resistors and nodes neatly. The LED lights only when both buttons are pressed. Any transistor off interrupts current, enforcing AND logic. When we press both buttons, the light turns on. If only one or none is pressed, the light stays off.
To construct an OR gate, connect the power supply to provide positive voltage and ground. Place 3 NPN transistors on the breadboard, 2 as input switches and 1 as the output driver. Add 2 push buttons as inputs, connecting them to the positive rail. Connect 2 kΩ resistors from each push button to the bases of the input transistors to control current. Arrange the input transistors in parallel so either can activate the output. Tie all emitters to ground. Place a 2 kΩ resistor between the input section and the base of the output transistor to transfer the combined signal safely. Connect the collectors of the input transistors in parallel to this resistor. Connect the LED with its cathode to ground and anode through a 330 ohm resistor to the output transistor collector. Pressing either button turns on its transistor, activating the output transistor and lighting the LED. The LED lights if either or both buttons are pressed, demonstrating OR logic.
And now, a story of teamwork and innovation. Two teams joined forces to create the legendary NAND gate.
NAND gate. For constructing NAND gate, we collaborated with Team 31. NAND gate consists of AND gate and NOT gate. We have two inputs at AND gate and output is shown in NOT gate. So we do not need LED in AND gate and push button, power supply module in NOT gate. We disconnect them from breadboard. Then we connect AND gate's output to NOT gate's input with the help of jumper wire. Finally, for current transformation, we link the breadboards. Now we can see the NAND inverted AND.
When we press both buttons, the light turns off. If only one or none is pressed, the light stays on.
And that concludes our coverage of the NAND gate, a powerful result of teamwork and precision engineering.
Truly inspiring. But after a few hours of logical thinking, even our brightest engineers need a bit of recharging.
Indeed, and now a short break from our engineering.
Welcome back to Breaking Logics. Refreshed and fully recharged, our engineers tackled their most ambitious challenge yet.
The XOR gate, a masterpiece of logic and teamwork. Let's ask our engineers about how they were able to build such a complex structure.
XOR gate. In order to construct XOR gate, we collaborated three other teams: Team 23, Team 43, and Team 49. First, we constructed NAND gate. As you can see from the previous part, all the construction details. We do not need LEDs in NAND gate and OR gate. Also, push buttons in OR gate, power supply modules in OR and AND gate. We disconnect all of useless parts for XOR gate. Then we have two inputs from NAND gate, and with the help of jumper wires, we connect NAND push buttons to OR gate's input for transfer current. Then NAND gate's output connects to one input of AND gate. Accordingly, OR gate's output connects to another input of AND gate. Finally, for current in each breadboard, we link the breadboard with jumper wires, as you can visually observe in the construction process. Now we can see the XOR, exclusive OR gate.
When only one button is pressed, the light turns on. If both or none are pressed, the light stays off.
And that wraps up tonight's special edition of Breaking Logics. From NOT to XOR, our engineers have proven that logic isn't just about circuits, it's about creativity.
Stay logical, stay connected, and remember, always check your connections twice.
Thank you for watching. 3, 2, 1. Thank you for watching. 2, 1. Thank you for watching.
En salak.
Benim adım söyle.
Aydın.
Böyle el. Ben böyle.
2, 1. Thank you for watching. 3, 2, 1. Thank you for watching.
El sallar öyle.
Sağ ol Eliye.
Necə belə?
Benim sağ ol öyle. Deneyeceğim.
3, 2, 1.
Thank you for watching. İyi speech diyorum ben.
Sallamayın.
Neyini
ye?
Biz için öderim thank you for.
3, 2, 1. Thank
Thank
you
you
for
for
watching.
El sallar.
3, 2, 1.
Thank you for watching. Başım bırak. Gel verelim. Thank you very much. Bu kadar sade.
3 saniye çözdüğünde
Bir de gidersin başlıyor.
sen kaybı almışsın orayı.
Arkadaşlar bak.
Ya Allah.
Thank you for inviting us.
We're watching breaking logics where zeros and ones became breaking. Hemal Mehmedova and Şahin Gulliye. Bir de two approaches. One true approach değil. Approach değil.
Flashback.
Two approaches. One truth.
End of flashback.
Logics. From NOT to XOR.
Güzel.
And that wraps up today. Isn't just about circuits.
Circuits.
Circuits.
Circuit. That's all.